The final portion of this lecture series on Hydrosphere and Oceanography will discuss about the salinity. Simply put, salinity means the amount of dissolved salts per unit mass of water. Salinity is expressed as the number of grams of dissolved salts in 1000 grams of sea water. The average salinity of sea water is 35 per thousand or 35%. It means that in 1 kilogram of sea water there are 35 grams of dissolved salts. The very composition of generally salt in every cubic kilometer of sea water, there are 41 million tons of dissolved salts, and their very share of different salts, as we found sodium chloride contains 77.7%, magnesium chloride 10.9%, magnesium sulfate 4.7%, and calcium sulfate 3.6%, and finally potassium sulfate 2.5%. These salts are mainly of terrestrial origin. Salinity determines the compressibility, thermal expansion, temperature, density, absorption of insolation, evaporation, and humidity. It also influences the composition and movements of the sea water and the distribution of fish and other marine resources. The very distribution of salinity, there are two aspects. One is horizontal and the second one is vertical distribution. The amount of salinity varies from one part of the ocean to another, and this variation is influenced by certain factors such as difference between evaporation and precipitation. Second, the stream runoff. The third one is freezing and melting of ice. The fourth one is atmospheric pressure. The fifth one is wind direction. And the last one, or the sixth one, is relating to movement of the sea water. The areas of highest salinity are found near the tropics, from where the salinity decreases towards the equator and towards the poles. This is because at the tropics there is active evaporation owing to clear skies, high temperatures, and the steady trade winds. In the Atlantic Ocean, the salinity near the tropics is about 37%. On the other hand, near the equator there is heavy rainfall, high relative humidity, cloudiness, and calm air of the doldrums. The equatorial region of the Atlantic Ocean has a salinity of about 35%. The polar areas experiences very little evaporation and receive large amounts of fresh water from the melting of ice. This leads to low levels of salinity ranging between 20% and 32%. Thus, maximum salinity occurs between 20 degree north and 40 degree north and 10 degree south and 30 degree south latitudes. In the open seas, the variation in salinity level is less pronounced compared to the partly or wholly enclosed areas. For instance, in the Baltic Sea, salinity increases from 11% near the south Swedish coast to 20% near the head of the Gulf of Bothnia. Black Sea receives many rivers and thus its salinity is 18% only. The Red Sea, on the other hand, experiences great evaporation and there are no rivers falling into it. Therefore, it has a salinity of 40% or more. The salinity of the island seas or the inland seas and lakes is very high because of the regular supply of salt by the rivers falling into them. Their water becomes progressively more saline due to evaporation. For instance, the salinity of the Great Salt Lake of United States of America, the Dead Sea, and the Lake Van in Turkey is around 220% to 240% and even 330% respectively. The oceans and salt lakes are becoming more salty as time goes on because the rivers dump more salt into them, while fresh water is lost due to evaporation. Further, we'll discuss regarding subsurface salinity with depth. The salinity also varies, but this variation again is subject to latitudinal difference. The decrease is also influenced by cold and warm currents. In high latitudes, salinity increases with depth. In the middle latitudes, it increases up to 35 meters and then decreases. At the equator surface, salinity is lower. So, this is all about salinity, which is an vital and important part of hydrosphere and oceanography that we have discussed in this lecture. So, above all, in this very series of lectures relating to hydrosphere and oceanography, first we have discussed relating to the very composition of the ocean and their very division as continental shelf, continental slope, continental rise, abyssal plains, then submarine ridges, abyssal hills, submarine trenches, submarine canyons. Then we discuss about ocean currents. They are particularly the meaning of ocean currents and their different times, such as warm and cold currents, and found in different parts of the oceans of the world, in particularly Pacific Ocean Atlantic Ocean, Indian Ocean, and the very name of such warm and cold currents. Then we discuss about tides. What is the very different meaning of tide and the various causes relating to tides, and in particularly the spring tides and nip tides. Then we discuss about coral reefs, their meaning and types such as springing reef and the barrier reef or the Great Barrier Reef on the coast of Australia. Then we discuss about the marine resources that we derived from ocean, in particularly mineral resources, biotic resources, energy resources, and how we derived energy from tidal waves. Then finally we have in this lecture discussed about the meaning of salinity and the very composition and forms of salinity in different oceans and seas and lakes. So hereby we complete our lecture series on discussing another important portion of Earth's structure, that is hydrosphere and oceanography, as because in our previous two lecture series already we have finished lithosphere or the solid portion of Earth, and in the second series that we have discussed regarding atmosphere, the gaseous portion of Earth. So in our next upcoming lecture, we would like to discuss some left out portions relating to civilizations, such as the Egyptian civilization, the Indus Valley civilization, and the Chinese civilization.